Your face and your mouth are the gateway to almost all social interaction, whether that's eating, talking, or even kissing a loved one. Now imagine if these basic everyday functions became painful or even impossible for you to perform. Unfortunately, this is not my imagination, but a reality for 150,000 oral cancer survivors living in the United States today. In each year, 20,000 more are added to this number. This condition, called trismus, is actually due to the cancer itself or its subsequent treatment, like radiation therapy, that causes these muscles and tissues around the jaw to stiffen. Now, you might think that this type of cancer stems from smoking and drinking habits, but really, there's a new emerging population where the cancer stems from human papillomavirus, or HPV, where these patients are young, never touched a cigarette in their life, healthy adults. And they have to live the rest of their lives with the consequences of limited oral function, which leads to a staggering economic impact. But regardless of where the cancer originates, I think these patients deserve better. My name's Michael Young. I'm a master's student in aerospace engineering. And the purpose of my research is to relieve these patients of their symptoms by building a wearable robotic device that can provide patient-specific therapy. Additionally, it can run real-time diagnostics to pinpoint those troubled muscles so that the physician can make a better long-term treatment plan. Behind me, you'll see a computer representation of my design. I came up with this design after over 100 interactions with doctors and patients across the country. These patients have to undergo therapy 3 to 7 times a day at upwards of 30-minute intervals. Just try to add over 2 hours of therapy to your full-time workload and family life. It's obviously less than ideal and sometimes just flat out impossible. That's why you see this hands-free headphone-like design. So let me tell you how it works. In each headphone, there's a series of motors and sensors that can manipulate the jaw to perform stretching exercises, but also collect data for diagnostics. This data is plugged into a mathematical representation of the jaw, and then we solve for certain stiffness parameters that define each muscle. Now, what do I mean by stiffness parameters? If you can imagine a spring, when you pull on a spring, you feel some resistance. This resistance is dictated by the stiffness of that spring. So although the muscle is a bit more complicated, we're essentially solving for the 20+ spring stiffness that surrounds your jaw. And we're actually able to do this with less than 2% error. Now, this is just one small step towards actually making a difference in the lives of these patients. But hopefully, this work will lay the foundation so that oral cancer survivors can one day eat, talk, or even kiss again to live out the rest of their lives with dignity. Thank you.